Yeah, we are going to solve the problems. It is very easy. The with Bharati station of all Indian radio, Delhi, broadcast on the frequency they given. You see, first question I want to write given the Vivek Bharati station of all Indian radio Delhi broadcast on the frequency. They given that frequency. Correct. Now we can write it is a symbol of frequency. Frequency how much? The 1368 kilohertz. They given that kilohertz. Okay. Calculate the wavelength. They're asking that to find out wavelength. Okay. Of the electromagnetic radiations emitted by the transmitter, which part of the electromagnetic spectrum does it belongs to? Okay, we know that already. They're telling that part means the radiation. We know that light is from a wave. It travels in the speed. C is nothing but speed. Correct. Now velocity 3 into 10 to the power of 8 meter per second. We can convert this into frequency 1368 kilohertz. Correct. Now we can convert it into seconds. 1368 into 10 to the power of 3 seconds per seconds. We can write it. We have the formula to find out the lambda. Lambda is equals to C by mu. We know the C value is nothing but 3 into 10 to the power of 8 meter per second divided by, we know the frequency value 1368 into 10 to the power of 3 seconds. Seconds cancel. Okay, if you calculated, you will get the value 219.3 meters. Wavelength is 219.3 meters. You see the problem means, if you see the graph of what the previous class we discussed, the electromagnetic spectrums, these meters will come in the radio waves. These meters will come at radio waves. Okay, next question we are going to discuss. The wavelength range of visible spectrum extended from violet 4 extended violet 4000 nanometers. It is they given that violet wavelength is how much? 400 nanometers is nothing but, okay, we write nanometers. You can write in that 400 into 10 to the power of minus 9 meters. Next, what they do? Red. They are giving another color. Red wavelength how much? They are given that 750 nanometers. We can convert it 750 into 10 to the power of minus 9 meters. Express the wavelength in the frequency hertz. They are telling that express the frequency in hertz. 1 nanometer is equal to 10 to the power of minus 9 meters. Already I told that. Okay. Next, they are telling to find frequency. Of violet and red. We know the frequency for violet. You can write frequency is equals to c by lambda. We know the formula. C is already, we know that light speed 3 into 10 to the power of 3 into 10 to the power of 3 into 10 to the power of 8 meter per second divided by, what is the given for violet? Lambda 400 into 10 to the power of minus 9 meters. Okay, next while solving this we will get 7.50 into 10 to the power of 14 hertz. So how you get the 14? If you minus 9, if you go to upside, become a plus, it become 10 to the power of 17. If you change the decimal points, we will get 7.50 10 to the power of 14 hertz. Next, similarly we are going to write for red, frequency is equals to c by lambda. You can write straightly 3 into 10 to the power of 8 meter per second divided by how much they given? 750, correct? No, 750 into 10 to the power of minus 9 meters. We will get 4 into 10 to the power of minus 14 hertz. You see, violet frequency is more compared to red. If you write a Vib Gayar, if violet frequency is more compared to red is 4, while red is 4 frequency, the violet is 7.50, means it is increasing the frequency, then decreasing in the wavelength. It is inversely proportional. Frequency increases, then wavelength must be decreases. Okay, we can see first what they given for violet we got 7.50 into 10 to the power of 14 hertz. We got it, correct? Now next, red, similarly, yeah, the frequency range of visible region 4 to 7.50. That one I told here. If increasing the frequency, decreasing in the wavelength. Next problem. Calculate the wave number frequency of yellow radiations having wavelength. They given, we want to calculate. First you want to write a given, correct? No, they are telling to find wave number and frequency of yellow radiations is wavelength is equals to 5800 Armstrong. We can write 5800 into 10 to the power of minus 10 meters. Okay, first we want to find out what? Wave number. We know that inversely proportional to the lambda, means 1 by 5800 into 10 to the power of minus 10 meters. We will get how much? 1.724 into 10 to the power of 6 per meter. Okay, next we want to find out frequency formula. Frequency is equals to c by lambda. We know that c is nothing but speed of light, 3 into 10 to the power of 8 meter per second divided by how much the wavelength? 5800 into 10 to the power of minus 10 meters. If you do calculations, we will get 5.172 into 10 to the power of 4 per second. We got frequency and wave number. Okay, you see, sorry, here 10 to the power of 14, forgotten to write. You see, this is the wave number. What I told, that is the velocity of radiations, means light radiations. I already explained in previous video. Okay, next we are going to solve the last problem. Last problem, that is, you see, calculate the wavelength. They are telling to find out wavelength, means we can write the given wavelength. We want to find out frequency. We want to find out frequency and wave number we want to find out 3. Calculate the wavelength, frequency, wave number of a light wave whose period is 2.0 into 10 to the power of minus 10 seconds. The given time they are given. You see, they are given time period. The given time period is equals to 2.0 into 10 to the power of minus 10 seconds. They are given this. Okay, you see, we know the frequency is equals to inversely proportional to time period. Okay, inversely proportional to time period equals the given time period 1 into 2.0 into 10 to the power of minus 10 seconds. If you want to write this, you see, 1, if you send 10 to the power of minus 10 to the power of minus 10 to upper side, we will get 10 to the power of plus 10 2. Correct, no? 1 by 2 is nothing but 0.5 into 10 to the power of 10 per second. If send second also, we will get minus. Okay, if it become a plus, if you go to upper side become minus. If it is minus, if you go to upper side become plus. Okay, 10 for 0.5 into 10 to the power of minus 10 per second. We want to convert 5 into 10 to the power of 9 per second. We got frequency. Next we are going to talk about lambda. Lambda is nothing but wavelength. You can write wavelength is equals to C by frequency, okay, or mu. What is C? Speed of light, 10 to the power of 8 meter per second. Okay. What is the frequency? We got 5 into 10 to the power of minus 9 second per second. We cancel. You see, 3 by 5 is nothing but we will get 0.6 into, if you send this 10 into 8 minus 9, correct, no? Here you got plus, if you go upper side become minus meter, you got meters only. 0.6 is there, no? We go 8 minus 9 is nothing but minus 1. 0.6 into 10 to the power of minus 1 meters. If you want to convert this again, 6 into 10 to the power of minus 2 meters. We got wavelength. Last we want to find out wave number. Wave number is equals to 1 by lambda. 1 by 6 into 10 to the power of minus 2 meters. If you converted, you will get 1 by 6 is nothing but, if you send a minus is to upper side become a plus, correct, no? 0.166 into 10 to the power of 2 meters per meters. If you send to this side, 16.66 per meter. We got frequency, we got wavelength, we got wave number.